So let's start then. We have these topics for today: inheritance and polymorphism, and quite another small topics I will touch also. So let's basically revise what we already heard on previous lectures with help of our TAs. And let me remind you that OOP, the most important principles, is on the slide. It is encapsulation, inheritance, and polymorphism. So we will talk about inheritance and polymorphism. And you already had talked a little bit about encapsulation. And let me again ask you a question. What is encapsulation? Mikola?
So this is the principle that basically defines how we control the access to access and the visibility of certain parts of the code. So so that the developer does not need to know what are the details of implementation that does not matter for the usage of it.
Yeah, exactly. So details of implementation is quite important words here. So basically, let me rephrase, and the quick idea of implementation details we could hide because of encapsulation. So that's why we could develop complex systems without being overwhelmed with complexity. Detail by detail, part by part, we just encapsulate, we decompose our system and encapsulate some complex details and provide to outer world just some simple stuff, and encapsulation helps us with that. Okay, and inheritance and polymorphism, this is our talk. So again, just syntax of inheritance. You know that I just the same information, and let's revise it one more time. So extends, this is keyword which helps us to extend saving account from bank account. So bank account is a base class, correct? This is our previous developed some class, and we want to extend functionality or behavior or attributes of that class. So we extend bank account and create new class which inherit from that savings account. Okay. The interesting detail I would like to emphasize that we have this word super. So what super stands for? What is super? Someone else?
I think it means that it calls the superclass as a superclass. Yeah, the super basically is the superclass. The class, for example, here is bank account.
Yes. So super stands for bank account. Maria, do you want to add something? Okay, so we just should know that super, it is about descendant, okay, or like parent class. This is just synonym. We could say parent, but here we use in Java super. Okay, but what is this in general? Of course, we have this description, but could you pay attention to that? Super, and then this syntax. What do you think? What is that? Super, parenthesis, and something. Yeah.
No, you call the constructor of the superclass.
Ah, yeah.
With the initial balance as an argument.
Okay, and what do you want to?
Maybe
Constructor. Yeah, constructor of, so super stands for bank account, and we just imagine when we make it class name and brackets, it is just constructor call, okay? So we have this constructor call here. So it is common practice when you create some additional constructor in your new extended class, it is common practice to call parent constructor, because there could be some important stuff being done in parent constructor. So that's why do not forget to call parent constructor. It could be constructor with parameters, without parameters. It depends. But it's good practice. Do not forget, because it will not be called or so basically it differs in different languages. So but in this case it is really good to call parent constructor, and in this case you make it at the very beginning, and after that, when that class initialized with parent functionality initialized, you already could add child functionality, and this is how we create constructors. Okay. Do you have questions regarding constructor? Okay, so just pay attention to super, and you could also call another stuff with super, not only constructor. You could call methods with the same name, but here it is just very important regarding constructor. Okay, and we have some additional functionality in this class. So we have no overridden here. That's why it is just new method for saving account, and there is no such method in bank account. So it is just pure new functionality, and we just created that. Okay, why not? Yeah, the question.
I just wanted to make sure, is our superclass a bank account or savings account?
Bank account. So bank account is a parent.
Can you explain again what is inside the brackets? What is this?
Here?
Yeah, what is this function? What is this argument?
Yeah, so there is no I can't show you bank account here because it was somewhere. So just imagine that we have constructor in bank account. We have constructor with parameters initial balance. And here in child class, we call parent constructor and just pass parameters there. That makes sense.
But we have the same parameter in savings account, like double initial balance.
This one, right? Exactly. This is a good question and good point. So to keep functionality of our class, we maybe will need some parameters for superclass and some parameters for new class. So that's why we have this. This is basically inheritance. So we have something from parent and something new in child. But to keep that functionality, to keep it alive, we should really pass kind of inherited initialization parameter. And just pass that parameter into previous constructor. That's it. So we just make it transparent.
We take the value from a child class and get it into the parent class by super.
Yes, we take, so let me draw it. When I create variable, how we call it, savings account. So we create variable type, saving account. Then variable name, A. Then what should I put there? What next? New, exactly. New. And we take this constructor, savings account. Okay. Our constructor has parameters. Hello. That's why we should put these two parameters here. So I don't know, something like, I see it is double and double. So two numbers we put here, okay? So syntactically it is correct code, right? Then what we will have under the hood? Under the hood, we just come to this method after this line. We come to this constructor. And you could imagine these two classes like, let me visualize it. Maybe it is not so strictly correct visualization, but still. We have savings account, let's call it savings account. And inside the savings account, we have basic functionality of bank account. And all this stuff we call super. So this is functionality of superclass. So that's why we take these two variables, and first of these variables we put into functionality related to parent class, okay? So we put this 10 somewhere here. We don't know exactly what parent class does with this variable, with this value. We don't know. We don't need to know. It is implementation detail. It is encapsulation. So parent class do something with initial balance. It puts some in some variable, in some private variable. We don't care, basically. Maybe check something, yes. Yeah, but this is the principles of encapsulation. We just put this value here. And another value, interest rate, we put somewhere here. And here we already know where we put it, because we have interest rate. It is specific variable here. And we put this variable into this parameter, into this variable. So you could think and consider our object saving account like object which consists of previous functionality, previous class, and new functionality. It is mixed. It is child. The same like analogy like in biology. Some previous inherited abilities of something, some animal, I don't know, and something additional, because children not always identical to parents, right? So they could have some additional features. This is it. So this is parent features, and this is new features. Does it make sense?
Yeah,
A bit? Okay.
Yeah,
Sorry. Okay.
So if we want to use a method which was in bank account class, we can like use it, and for that we need initial balance. And that's why we need to like write the super initial balance.
Yeah. Could you repeat, please?
Okay, so if we have some method inside the bank account class,
In bank
which
account.
we
Okay.
want to use which we want to use via the object of savings account class.
Here. Okay.
Yeah, so we have this an object of this class, and we want to use the functionality of bank
Yeah.
account class.
Yeah. Yeah.
So and for that we write like super initial and initial balance, and with the initial balance we can do something.
Okay.
I think it is like instead of writing again the code in
Like
the method, we just get the super and then like connect it with the value that is in
Yeah.
our
This is kind of the bridge, the way how we come to parent class. But if
Why can't we just instead of writing super write that like bank account just to connect the code?
this also makes sense. This also makes sense. But super is just more universal way, and you don't need to remember exactly. And again, in different languages, it is this functionality is possible. You could directly call class, because you could inherit from many classes. I mean, in your hierarchy of inheritance, it could be many ancestors, and you could call exactly that ancestors method. So yeah, that makes sense, but we don't really do it a lot. So, but I want to bring a little bit more details. For example, you have method, I don't know, some do something. Okay, we have method do something in bank account. Question to you. Two questions basically. If I want call this method inside saving account, what should I do? This is first question.
Inside the class?
Inside the class. And second question, if I want call this is by the way public method. If I want call this method in outer world, what should I do? So these two questions I would like to ask you. First answer. What your Maria? Super dot do something. Super dot do something. It will work. It's correct answer. But you could even do it without super. Why? Because if you have no do something in saving account, you could just call do something, because everything which belongs to your parent belongs to you, okay? So it is easy. You have method do something in your hierarchy of inheritance, call it. You don't need to specify super every time. You just use it and that's it, okay? So if I have overridden do something here, then I just call do something inside my class, okay? Does it make sense? The same way as I call, I don't know, this. By the way, this is exactly what we're talking about. Get balance, as you see, we have no get balance in saving account, right?
It is from bank account.
It is from bank account, and we just call it. And it's syntactically correct, right? Another question, if you want to call get balance or do something in outer world for A, what will you do?
Can I ask a quick question? If in our parent class we have, you said that everything that is in parent class is in child class.
Okay.
What if something in the parent class is private?
Then you can't connect that, can't access that. Good question, but wait. Please give me the answer to my question. I want to call do something. It is parent method, public parent method, in outer world scope. What should I do?
I think basically A dot do something.
A and do something. Do you agree? Exactly. Everything which belongs to your parent belongs to you. That's why it is absolutely correct. You just call parent methods, and there is no problems to do that. So yeah, I think now we go to that question from the list. But at this point, so we don't call A super in outer world. Okay, it is not possible. Super only for our inner encapsulated scope. Super only for this. This is our private family things, okay? Nobody could call super in outer world. So just remember that. And let's move to your question. Could you repeat that?
Yes, I was talking about, you said that everything that is in child class in the parent class is in child class. What if we have some methods and functions that are private in parent classes? Can we connect somehow it in child class?
Great question. So let's remember, everything which is private, you can connect, you can call, you can access only in this particular class, nowhere else. Yes, we will learn about nested classes. This is something new concept, but we will talk about that later. Now let's say from the perspective of inheritance and from the perspective of outer world, private, that's why we call it private. It is private stuff. Private even for parent. This is not for children. This is private. Sorry.
Our get balance, it was public. Right? Our get balance was public.
Exactly. Get balance should be public or protected. This is another story, which is very related to your question. So first, private you could call only inside and it is full encapsulation. It encapsulated in parent class, and even children can't access that. And of course, outer world also could not access that. But we have protected. Protected means that it is the same as private, but children can actually access. If, I don't know, some method be protected in parent class, you still could access this from child class. Again, this is kind of family stuff. Children have access to protected, but outer world have no access to protected, okay? So, but basically, in most cases, we still use private if you're sure that it is just, you fully encapsulate this logic. Just make it private, and let no children could access that and change that and broke your class. So in most cases we still use private, but sometimes we decided, yes, it is protected, it should be accessible for children. That's why you use protected.
How do we use, how do we point it out in our UML class diagram? Because we have minus for private,
Yes.
plus for public, and what do we have for protected?
Sharp.
Okay.
Actually, barely seen usage of protected in actual production code. Almost never seen it.
Yes, yes. So it is just option and we don't really use it much. Yeah. Okay, very important. Very important. So any other questions regarding inheritance syntax? Do you understand the idea of inheritance? It looks nice. Yeah, why this stuff was created? You should understand. It is not just idea from biology. It is idea how to implement this programming principle. Yes. Do not repeat yourself. You already implemented that in bank account. That's why let's just inherit that class and add some functionality. And we should not repeat ourselves and create new get balance method or call some another public business logic method. It is already implemented. I don't need to repeat myself to write the same code.
And also
That's why we use inheritance.
And also do not overcomplicate those.
Yes, but in the future we will talk, or you will read or know about it, that still there are trade-offs regarding inheritance, and if you have really long hierarchy of inheritance, maybe you do not repeat yourself, but it makes your code so complicated, so interdependent, and so complex that sometimes you could say, maybe I will just repeat myself and don't make this awful stuff. So everything in software engineering is trade-off. You always make trade-offs, compromises. But generally you should know, do not repeat yourself. Inheritance really help to do that. Right. Okay. Let's move forward then. Again, a little bit about overriding of methods. So we have nice discussion, and you asked a lot of questions. Why override? Why we put this interesting syntax with this mark and so on. So again, this is just helps you to override with consciously. You understand what you're doing. You don't make it just by mistake, or just use the same method somehow. And so compiler will ask you, do you really want to override this method? So that's why when you put, yes, I really want to override this method, come on. I know what I'm doing. And that's why it really helps. It makes your code readable, more readable, because you purposefully override some method. Okay. Now I want to ask you a question. So we have this overridden method, withdraw. Tell me, please, about this method in bank account. What you know from this syntax about this method regarding bank account, not saving
It
account.
accepts an integer or double.
Why integer?
Or double. Not sure. You can judge from here, I guess. Oh, or you overwrite and you know.
Exactly.
That's
We override.
Okay.
That's why I'm asking. We override. That's why we know, actually.
Yeah, but I remember if we overload, we could have changed everything there, but we override, so we have.
Yeah, but not mass overloading and overriding.
Yeah,
You
yeah.
could overload,
But it's not like. Yeah, I
but you
remember.
don't need then to override that.
Yeah. So okay, override. We have double. It returns nothing. Basically,
Yeah.
it's public. But also
So basically the same signature of the method. That's why we call it override. We replace, we rethink we recreate, we remodel, we just decided that we want to change specific functionality. And this functionality, like parameters of this functionality should be the same. So that's why I know that in this class, I have the same method with some functionality. But in saving account, now I want to recreate this method and create another functionality for this method, okay? Yeah.
If we had the different name of this method, do we need to write override or not?
Good question. If we want just withdraw with without commission, for example, then it is just new functionality. You create another name. You do not overwrite anything. You just add new functionality. And it is not overridden method. It is just new method. But if you have the same parameters and the same method, then you override.
So if we overwrite in our class savings account, it is a new withdraw in our savings account, but still it exists a previous one in bank account, right?
Yes.
It is only because of we use override.
Yes. So let's say not because we use override, but because we override. So override annotation, this is just helper to us to proclaim, I'm really overrided this method, I know what I'm doing. But the essence of overriding, it is creating method with the same signature in parent and in child class, that's it.
And what if I didn't use override but still had the same name?
You still override this. You still override this method. But this,
If I didn't write it.
you could not write it. But maybe another programmer, maybe Mikola, will open your code and think, what did this think when he wrote this method? Does he just want to create new method, or he really want to override, or he just override that by mistake?
So
What that basically mean?
More comment.
Yeah, it is kind of comment. It is kind of help to you, to compiler, and to other people to ensure that you really want override.
But I would not have an error in my...
I think you will not. You could try, but as I know, you will not have error. It is a new kind of functionality was added just because just to help programmers understand their code and share their code and make it more readable and more purposeful creative.
And don't make my head explode while I'm trying to understand what's the meaning inside the head of the previous developer who
Mhm.
worked on it.
Okay. So, could you create or tell me some new examples of overriding of method? Just let dream a little bit. Let imagine. Let train our imagination. We want to create inherited class from other class. What it could be, and we could override some functionality. What could it be? Yeah, Mikola, first example.
Yeah, from my production project, basically, user interface, console user interface, the method is to render something.
Render. Okay.
Yeah, so it has a lot of parameters actually, as it's my production project, for example, the x coordinate, y coordinate, type of object, so on and so forth. Not actually, doesn't actually matter much. Yeah, and let's think.
So what examples of child classes?
Child classes.
How you call this class?
I call this class user interface.
UI. Okay.
UI, yeah.
And how you call children? Some of your children's classes?
Console interface.
Ah, okay.
Basically the TUI.
Oh yeah, I see. So you just create ability to make either console application or even graphic application.
Yeah, this was basically my text-based video game, which could use some front ends for it to be portable to Android, to iOS, to other stuff, and the console for just the basic usage, like some options.
Okay. So let me summarize. We have render UI, some abstract user interface, and we extend this class by two different possibilities. Console interface, which is text console application, and every of that methods has render method. And we override this implementation of render will differ of this implementation of render, okay? Okay, that makes sense. Let's imagine a bit more. What other examples could you provide? Try to think. We have class and we have child class. It could be from, not from programming world, but maybe some more common. Okay, Igor and then Marta.
Yeah, we have, for example, geometry, like figure class, like geometry figure.
Or shape, yeah?
Shape.
Mm-hmm.
Shape class. And for example, shape has perimeters. So we can have
Yeah.
circle with perimeter, a rectangle with perimeter, and so on.
Yeah, so we have this get perimeter method, and we have different figures or shapes like triangle or rectangle. And every of that method has get perimeter and get perimeter and different implementations because these different objects really, and we should different geometry like calculations. Right, that makes sense, Marta. Hobby, okay. Uh-huh. So what in common for hobby, readings, and movies? What in common? What method could be in common? Rating. Okay. To rate what I just consume, let's say, yeah? Okay. Let me call it to rate. Yeah, and because of it is readings, we will rate books. If it is movies, we will rate movies. Okay, I have one more idea, like to spend time. I don't know how to call it in. So, if we have hobby, basically this is our activity. So we will act. In case of readings, to spend time will be read some books, and maybe we will, I don't know, do something, print in console that I read this book or something like that. And in movies, that would be watch the movie. So we have different, regarding the hobby, we have different spend time function, okay, method. Yeah, that makes sense. So hopefully you understand the idea of how we use override. Okay. Now, the most interesting part and the most important part, and you already had a taste of that polymorphism understanding, but let me start with definition. Polymorphism is a core concept in object-oriented programming that allows objects to be treated as instances of their superclass. One more time. Allows objects to be treated as instances of their superclass, even when they are instances of a subclass. So again, I have hobby object, and somewhere in my program I created readings object. But in my program I have ability to treat with these readings just as with hobby. What I know about hobby? That I could act like to rate or to spend time. I just call these methods, and I should not think, or which method will be called from readings or from hobby. I don't care. Java helps with that. This is polymorphism. So, or in this case, shape. I have in my program different shapes. Imagine that you create editor, and you put many shapes in your editor. Yeah.
available.
So
And with updates, they will
many, and you constantly could update. And in some moment, you want to calculate some of perimeters, or how we call plоща, area. Some of all this area, you want to calculate that and to summarize all of that. You will not come, or if this is circle, then, if this is rectangle, then, you just call for every object, you just call area, get area. And that's it. And you put it in some accumulator, in some variables sum, basically. And you do it in for loop, and you call for every object get area. Doesn't it beautiful? You should not call, or it is square, then this formula, then that. You just call get area, and it is already encapsulated somewhere here. And you don't need to specify specific like particular implementation. You already had that under the hood. I want you to reflect a little bit, to think about it. So, very classical example is this. Very understandable. Every book, every ChatGPT answer will start with this example. This is a good example. So what do we have here? We have animal class. Okay? Animal could make sound. Wonderful. We have abstract animal. We don't know which sound, actually some sound. But then we create dog, which extends animal, okay? And we override make sound with this particular implementation, bark. Okay? Make sense? Dog, make bark or have in our language, or something else in different languages. Okay. Then we create cat. We also extend animal. And we again override make sound. And in this case, we have this meow. Okay? Then you should pay attention to this. You should understand this. This is the most beautiful part. In this main method, we create, look, animal. Type of every of that object's animal. Not dog, not cat, but animal. So this looks weird. Pay attention. You create animal, but you run constructor for dog. Do you see? You can do it with other like data types. If it is not inheritance, this is error. But because of we inherit from animal, then you could do this magic. Yeah, Dennis, your question.
Yeah, I just so instead of just a dog, we could write animal, but
Yeah.
we have got encapsulation and inheritance.
We have inheritance with dog. Dog is inherited from animal. That's why this line is possible. The same with hobbies. I could create here, I could say it is hobby, but I create any hobby I want. And there is no syntax error here. This is correct. Because this generalization relation, we call it is a relation. Graphic UI is UI. Reading hobby is hobby. Rectangle is shape. Dog is an animal. That's why it is correct to create, to have this line. Everything is correct here. Okay? Do you understand that? Now, this is introduction to most beautiful part, and this is basically the most beautiful part. This is the most beautiful part. Now, we take, let me start with dog. We take object of our class and we call make sound. The question to you guys, which method will be called in this line? This one or this one?
The dog's one.
Why?
Bark.
Let me discuss, let me contradict you. Wait a minute. So, look, guys, my dog is basically animal. If I have animal variable and I call make sound, why it should not be this method? It should be basically this method.
Because we wrote new dog. Why?
Because we extended our dog, like our dog inherited the class animal. That is why we призываємо when is my dog, our class dog.
All your answers are correct. Because, and this is magic of inheritance, and this is magic called polymorphism. So are object polymorphic? They just relate to a parent object, but they behave in their own style. And compiler knows exactly what happened here. So when runtime environment come to this line, it takes, okay, my dog, what class of my dog? Class of my dog is dog, right? Make sound. Let's call this method. Let's check our class. Do we have make sound method? Yes. That's why we call this method. If we have no this method, then runtime environment come to parent class. Do we have parent class? Yes, we have it. It's animal. Let's go to animal and search for make sound. Do we have make sound? Yes, we have. Then we call make sound. But it is if we have no this method. But we actually have this method. That's why we call bark. We call method of dog. The same happened here with cat. Do you understand that? And I want you to understand that this is actually beautiful. This is actually kind of magic. Because you call animal, you call method for animal object. But runtime environment somehow know that you should not call this, but you call this. And in such a way, you could create any hierarchy, you could create another shapes, you could create wherever you want. And when you call method, runtime environment will use that needed method for specific object, not for just data type class, but for inherited object. So this is tricky, and this is polymorphism, and this is really, really nice to have, and you should understand that. Let me ask you, what do you think, how compiler could, or not compiler, how runtime, this is runtime, not compile time, how runtime environment could define which method to call? So let we come to this line. What do you think? What runtime environment will do?
It firstly checks the cat class and only then the superclass.
Yeah, so first of all, we check the cat class. We check the actual object class. And after that, we just check other classes. What do you think? It could be quite, it take more time. Yeah, so we could have problems with performance, does we? So, or do we? Because if I have a long hierarchy, I should check, or does it, this class have this method, or no, this method we have no, and so on and so forth. So it is kind of take time, right? So it is kind of performance issues, but we call this method virtual methods. And you will read, by the way, this information in our readings. And runtime environment create for every class, for example, I have this mass on my whiteboard. So for shape, it created table with get perimeter, get area. Then we have rectangle. It creates again its own methods, get perimeter, get rectangle, and it takes, even if we have more methods from parent class, it also put all that method in this table. All previous method from whole hierarchy, it put in this table of methods, and when runtime environment tried to run the method, it looked to this table, and it should not really come to, or what is my ancestor, what is that ancestor, and come to hierarchy. It did it before it ran, and it already have it, and very quickly look to the table and call needed method, even if this method from superclass or this class or overrided method and so on. Okay, this is a bit of technical details. Please read readings to understand, to extend your understanding how virtual methods actually works. Okay, I think we could make pause here. Yeah, and what do I have more? Casting abstract class. Yeah, just one slide more. Regarding polymorphism, sometimes we need to do interesting stuff by ourselves. Instance of and typecast. So for example, you are here and you in for, and you come to each object. And maybe for some of that object you have some specific functionality not present in parent, and you want to call that specific functionality. You can't call. So what the problem? If you have animal here, you see animal make sound, and you really have dog object in this variable my animal. So the same as in previous slide, okay? You have this dog object, and your aim is to call, where is that? This one, fetch like принеси, apport. So you want to call fetch method. Fetch method is present only in dog. Fetch method is not present in animal. But your animal object is object of animal again. So you try to call fetch for animal. Now magic stops. Now magic will not work. This is not polymorphism. You can't call child methods for variables of type of superclass. So without this code, you can't just call this method. My dog of animal. What is this my dog? Dog, my dog. It is another variable. Okay. So if it my animal, I could not call just fetch for my animal. Do you see? We have magic in polymorphisms, and we also have stopping blocks. It is this magic is not possible. I can't call for animal type. I can't call this fetch. This will be runtime error. Yeah, I will jump into that in one moment, but I want you to understand that you cannot call child methods in parent data type even if it is actual object of child. Is it dog? Yes, it is dog. Can you call fetch method for my animal? No. No. Because animal data type has no fetch method, right? That's why I can't call this method here, even though it is actually present in object. But this is compiled languages. So in compiled languages, this is not possible. In dynamic languages like Python or others, so you could call that. Maybe. I'm not expert in Python. Let me be sincere. but in interpreted languages, you could have this dynamic link regarding method. But in compiled languages like C++, Rust, like Java, you can't just call not existent method. That's why you have to do that tricks. So trick number one, you try to identify if really my animal instance of dog, very English phrase. Do you agree? If my animal actually instance of dog. So I try to know if this object just animal or really dog which inherited from animal. Because both is possible. It could be cat. It could be another bird, I don't know. But I want to know, is it really just dog? And if it is, then I make next step. I make typecast. Typecast, so parenthesis, then data type. So you say to compiler, now compiler, look to me. Now compiler, listen to me. I know exactly that my animal is basically dog. No errors here. You could trust me. And I put new variable of dog, and dog has fetch, and that's why I could call this method.
So like we always need to create a new variable or to...
Good question, Sophia. Basically, we don't need to create new variable. We could put it like this. We could make it in one line without creating new variable. Just in this example, creating new variable make it more visual. So I could call in this way. Typecast my animal. And then, because here I already have dog object, I call what? Fetch. So it makes this code a little bit concise, but maybe a little bit more complex because of some parentheses and so on. But actually, we really don't need this variable. But to access specific methods of child class, we need to do typecast. This is the main message to you.
Can we do typecast only with classes?
No. Good questions. Good question. You could do typecast with everything. So you could, for example, typecast to int something. Some maybe double variable. Put here some variable. So you could use typecast for everything. Of course, you could have errors. If typecast, if it is not dog, you will have error here. If it is not possible to typecast to int this variable, you will have error. But if it is possible, you will have this casted new value of another type. So typecast is universal approach which works not only with classes but with other data types too. Any other questions? Okay. Not rocket science, but still, yeah, so something. Okay, let's make a break. So, few more concepts about object-oriented programming. Abstract classes. So, again, all this syntax stuff, this is just syntax. You should understand the main idea. So basically, what is abstract class? This is class which is not supposed to be instantiated, or we're not supposed to create object of this particular class. So for example, remember that example regarding animals. We had animal and we could actually create animal, right, object. And that object will make, which sounds do you remember that println? No, animal. Some sound. So nonsense sound, we could say. So basically, that would be better object-oriented modeling or design when we create animal like abstract class. And we say to programmers, oh, wait a minute, programmers, do not create animal class. Please create dog, cat, bird, anything, but not just animal, because this animal is just abstract to inherit and to create good, let's say, full functional objects. This is the idea of abstract classes, and it used a lot. Let me show you how it works. To create abstract class, first you put abstract before this class and name of the class. And to make a class abstract, you should also have at least one method which have no implementation. Look to this method. What is that? Where is my curly braces? Where is this stuff and where is this implement? No, there is no. Just semicolon, that's it. This is the way how we create abstract method. So abstract method has no any implementation in abstract class. In our case, regarding animal, we could make sound abstract without any implementation, and then override that in new inherited classes. So like here, for example, shape, by the way, this good example which we already considered. We have circle which extends abstract class shape, and then we must override abstract methods. When we inherit abstract class, we require it to propose implementation of that abstract methods. If our class not abstract. So circle is not abstract class, that's why we obligated to propose implementation, to override this method. So we override area, and it works well. This is the idea, yeah.
So our abstract class is our parent class?
Yes, exactly, shape. And here we have shape.
How can our parent class be abstract, like without any,
Think about it, yeah.
Does our abstract class optimize the program, or why do we need to use it?
Okay, this is a good question. So there are several reasons. First reason, this is just conceptual, like common sense reason, like with animal. What the sense to create animal if there is no such thing like animal, I mean general animal in this world, okay? We have no just abstract animal, is it correct? We have either cats or either dogs and so on. So there are particular animals. There is no abstract, oh, I go through the street and meet, finally I found animal. There is no such thing like animal. This is fully abstract concept, right? So we not wait on the streets to see, or in zoo to see any animal. This is not elephant, this is not monkey, this is just animal. This is just not, have no any sense. This is abstract concept. And the same in programming. We could say that we will have this shape, but there is no such thing like shape without any specific thing. Yeah? So we say, let's make this shape abstract. This is just our abstract understanding of this domain area. But then we will inherit from this abstract concept, we will inherit particular specific concept which have sense. Triangle has sense. Rectangle has sense. Just shape, what is shape? Okay? So that's why we not wait in our program that we will do this thing, like new, like in this case, shape, yeah, new shape. No, we don't want programmer to do that. We want programmer to do either circle, either rectangle, and so on. This makes sense. This have no sense. So that's why when class is abstract, it is forbidden to create objects of this class. This is compile error. You just have no opportunity, possibility to just create this object, right? Even on compile time, this is forbidden. Create animal in our previous example. In compiler will not say you anything. It is allowed, but that has no any sense. We need to create specific. So in these cases, this is first reason, just like a common sense, let's say, okay, like design. Second is this. When you create this abstract something, you know that this thing will have some functionality. But at this moment, you don't know how to implement that functionality. So for shape, as we told in this example, you know that shape will have method area. You predict that. You require for inherited objects that this method should be implemented. But in abstract class shape, there is no any sense to implement area because you just can't do it. You don't know is it rectangle or triangle. You have no mathematical stuff to put here at this moment. So you just predict this behavior, and that's why you make this behavior abstract. So this is the reason, the second kind of related to first reason. Second, that some methods could be, at that moment, you just don't know how to implement them. But you know that your ancestors, your children, should have that methods. And you just predict that, put abstract, and forget. So this I could say two reasons. Make sense? Yeah.
Okay, can I do like shape, some name equals new circle? This kind of class. So I can
You mean like previous like polymorphism example, yeah? Yes. Good question, and you could do it. So you could have shape, abstract, s equal and you have new, but not shape. Shape is forbidden, but circle. And this is beauty of polymorphism. You can do it. Yes, shape is abstract, but circle is not abstract. That's why it works. Circle is a shape. That's why you can do it. It is okay. And you could then call S area, or how we call it, get area, just area. And it will perfectly work because this is actual object. Compiler allows you to do that, and you could call this method already implemented in circle, so yes.
By the way, if we have another method in circle which is not related to like shape at all, it won't work, am I right? As I remember.
At this point, yeah? So if we call S and we have additional method here, another do something, without typecast, you can do it. You should make typecast. If you make typecast, circle, then you could do it.
But what if we, for example, did circle as new circle equals to new circle, and we tried to call area from the circle? It will.
Yeah, it will work both area.
I just don't see why we need to like to do shape as equals to new circle, like because like if we can.
This one, yeah.
Yeah, why we need to like do the
Downgrade data type, yeah? To downgrade data type.
If we can.
Make just circle.
Yeah.
So this is good question. and this is our abstract thinking. So just let recall the same example. You create graphic editor, Photoshop.
Okay, I understand.
So you have this toolbox here. You push the button, you get different shapes. But you want your program to handle it universally. And again, you want to summarize. So you have array list
Ah, I see, of shapes. Okay.
of shapes.
Okay, yeah, I got it.
Yeah.
Yes,
And you just, in loop, could call
okay.
area. So this is kind of generalization of our, and this is basically object-oriented, where object-oriented programming starts. So two things, this is methods and class members, like you call methods, just create classes. In previous semester we did it, but now we have inheritance. And you could generalize some behavior and create, so this is a very cool feature of object-oriented programming. Okay, any other questions? So, abstract classes. You should know that. So, you could use them in your good hierarchy and just use that stuff. Okay, let's move on. Connected, just to question of Yegor, generics. When we put just this example, what is generics? So let me remind you example. Every one of you already played with that before, and now I will explain you what that basically mean. So let us have array list of shape. So generics, this is about these braces. This is generics. And we call it, let's call it again A. And we could call new array list. So nothing interesting here. But for us, it is very important to have this stuff. And then you have a, how we call it, add, right? To add something. And we could put new circle with some coordinates or something. We could put new rectangle. And we could put new triangle. So for us, it is very interesting stuff that related to array list. Now I don't want to talk about abstract classes, but I want to talk about array list. You played with array list, right? You try to put in array list different objects. What kind of objects have you put in array list? Could you recall? Could you remind yourself? Strings, integer, yeah, with and your custom classes. So think about it. You use the same class, array list, and you use absolutely different data types to put in that array list. How it could be possible? So in this case, this shape become, what it remind you, by the way? So almost braces, almost parentheses, like in methods. I agree with me?
Yeah.
So it is kind of arguments, but in different type, in different time. So this is argument for our data type. So let me show you in this example in more precise way. Let us create, for example, custom data types, generic box. And here we put this kind of argument And so this is just data type. This is just data type. And then we create variable of this data type. So let's just pay attention to that. So just the same, when you create variable, first when you create, when you declare variable, first what you put is data type, right? So this is our data type. But it is not string, it is not integer, it is not shape. It is just some, we don't know at this moment what data type will we have. This is for the future. And we create this data type, and we create variable of some data type, which we will know in future, of this data type, or array list integer data type, or string. Any, we don't need to know at this moment. And then everywhere we reference this data type. So this syntax is just similar for every other method or variable which you use. But you just use just custom symbol t. You could put t, s, a, any symbol you want to put. It is just your decision, like arguments, right? And you just reference this, you will have this return value of this future, you don't know at this moment, future data type, integer, or string, or shape, any of that. And then you use it in real life. How you use it? Generic box, then this parenthesis.
The same as with classes.
Hmm?
The same as with classes.
Yeah, so the same as with everything, with classes, with methods, and so on. But so pay attention that you play with this kind of parameters at the section of data type. Not in new, like not in this, but even here, when you declare your variable, you declare data type of this variable. And you define this data type will be generic box integer. This data type will be generic box string. Right?
So generic box is like an array.
At this moment, generic. Yeah, maybe. So let's try to discuss and to know. You tell me what generic box is.
Like, what is the purpose of generic box?
Let's think about that. What is the purpose? What behavior generic box has? You tell me. What methods and what attributes it has? Set and get some value. Of which type? We don't know. At this moment, we don't know, but we will allow any type to be put here. So what is generic box? So then this generic box has no any sense, of course. So this is just learning example. But still, this is generic box. This is box where you could put anything. And at the moment when you create this generic box, you decide what exactly you will put here. So if we have here integer, you will put integer. You define that in integer box. You'll put only integers and nothing else. In string box, you will put only strings and nothing else. And you basically use it. Integer, strings, and so on.
As I understood, for these boxes, we only can put one value inside.
One data type.
One value. I'm talking about value because we have private t and t. Like there's only one t and that's all.
You mean not array?
Yeah, it's not an array.
Yeah, so because it is created in such a way that there is no array here. If you open array list implementation in your IntelliJ IDEA, you will find array there under the hood. You will basically find. But here, you have just scalar value, how we call it, just one single value of some type, some data type, and this is it. So this is cool stuff, I could say. This is very, very useful. Again, you feel like a programmer, yeah, that you could, okay, with abstracts, with inheritance, I could predict some parameters. With generics, this is another idea of do not repeat yourself. Do you agree? Because if I have no generics, then I should create class integer generic box, which will keep only integer, and I will put integer here. And then I should create string generic box. So I should basically rewrite this class twice. But with generics, I will not repeat myself, and I will allow any data type to use this class.
But
Yeah, Mikola, just a moment, yeah.
Although with some caveats, as Java under the hood basically removes the type of the object and just casts it to the nearest point without type erasure.
Okay, Mikola as always go to very deep, too deep at this moment. Yeah, Dennis.
oh, my question is simpler. We use generic box. It is like an array, but in which we can input many data types, right?
Yeah, any data type, yeah.
But can we like input in one generic box either integer and string?
No. When you define variable, like here, you put that this generic box will have only integer. And you can't put here, for example, this string. You can't do that. Yes, Maria.
Can we write T in generic, like class generic box, T, comma, S, and send it to
Let me understand your question. Could you, like, you want to accept in the method the data type or what?
Yeah, like instead of one T, I accept one T. I want to accept several.
Here, yeah? At this, absolutely, you can do it. You can do it. And we have, for example, the map, hash map. This is the kind of data type when you put two generics, key, type of key, and type of value. So exactly, you could create such a some class, and you have two data types. You can do it, absolutely. And you use in your methods correct, you choose A is the T1 or A the T2. Of course, you could rename it somehow as you want, A and B. But yes, the answer is, this is a good question from Ray. You could use several generics create in one class. Yeah, it is possible.
And then a follow-up question. Should we necessarily use both of these data types if we do something like this?
You mean when we create object?
Yeah, for example.
You definitely require it to put both of that.
Yeah, here, there, I understand. And if we, for example, put something inside, so for example, if we have some kind of an array list which can accept both integers and strings, can we?
No, Igor. We don't talk about that array list could accept integer and strings.
Yeah.
Array list has only one parameter for generics.
If we create a custom data type,
Yeah.
which acts somehow like an array list and can both accept integers and
Like
strings.
this, yeah?
Yeah.
Okay.
Can we, for example, write put inside only integer objects and no strings? So,
When?
Huh?
When?
So we create
At
an
this-
ob- we
at
create
this-
an object.
At this level,
Yeah, and we say, for example, data type, object, and data type integer and string. It can accept. And when we put some values inside of this array list, like our custom data type.
Igor, when you put value, you mean this line or this line?
This line, the second.
Second.
Yeah. So can we put
Second, Igor, second line is dependent not on this.
Yeah.
It totally dependent of signature of the method.
Yeah, okay.
You could have this method with one data type. You could another method with T2 data
Right.
type.
Yeah.
And it just totally dependent on how you create signature of that
Yeah,
method.
makes sense, yeah.
Okay.
T1 and T2 are classes, right? Data.
Okay. Another good question. What T1, what generics could, what data types could be represented by generics? And in Java, it should be ancestor of class which called object. What are you talking about? So we have, as in your book, you will read cosmic object. Cosmic, like the super ancestor. And from this object derives everything in, not like this. We should put arrows backward to show generalization relation. For example, string. For example, my custom class. Even if you create just class like here, basically it is derived from object. Extends, you could put here extends object. Java make it for every class you create. Every of your classes extends this root of hierarchy called object, except int, double, char, and all these simple data types. It is not possible to use int, double, char, and what else do we have? So just float and so on. You can't use, because this is not objects. This is primitive data types.
Boolean too?
Sorry?
Boolean.
Boolean, yeah, exactly. So this is primitive data types. They are not derived from object class. So that's why you can't, now attention, now it be tricky. You can't do, pay attention and I will ask you questions. You can't do array list int. Hmm? Exactly. But what is integer? And now we come to like structure of Java. So this is exactly question which Java creators meet. How to put generics, how to use primitive data types in generics, because we actually need array list of integer. But we can't use primitive, and we use integer. Capitalized integer, not just integer, yeah. So and the same we have for every primitive type. So this is tricky. My goodness, this is just Java, guys. So every primitive data type have how we call it wrapper class, and we slightly come to just to next slide. We have wrapper class for every primitive type. Let me show you. So integer has integer, double has double, and so on and so forth. So pay attention to this source code. You see, this is integer. This is not int. This is integer. And integer is a class which define it. You could even jump to integer inside your IntelliJ IDEA, see what that integer means. So this is a very simple class which represents int value. It looks tricky. For us, for our understanding, for philosophical understanding, there is no difference between integer and int. They serve just the same purpose, just to keep integer values. But to be able to put integer into, for example, array list or as a data type like generic, Java creators created this fake, I don't know, this is not fake, this is just created like data type which derived from object. So integer here, integer, this is integer inherits object. And that's why you could use integer in generics. So this is just syntax trick which allows you to use integer inside array list. We could consider that in such a way, okay? So let me show you how it works. So for example, look here. We have just 5, and we could put int here and have 5. We also create integer, and this is kind of the same. New, because every object could be instantiated by new. New integer 10. Awful syntax. You don't want to create variables of just with value 10 with such awful syntax. But you can. You can. And so on. And then the most interesting part. Look, guys. What do you see here? This is not integer, this is int. But what is int wrapper? Integer. And it is absolutely allowed in Java. Okay? You could just play with this in both directions. This is called auto-boxing. And Java will help you with this typecasting, and you don't need to bother yourself, or it is integer object, or it is just primitive value. You don't need to bother yourself, but you can finally, you can create array list of integer values. This is it. This is the only way, the only aim for this out-of-boxing wrapper stuff. Okay? So you create array list of integer, you add integer, you don't put new integer 10, you just put 10 here, 20. You have just integer value and get from the list of integer. You get integer value, just simple primitive integer value to num. So no typecasting here. No, you don't need to bother yourself. But this is just the way how it works. Do you understand that? Okay? So this is trick in Java language. Not many languages has the same integer object, integer primitive value, but here we have it, and it makes sense because of generics. We need to do that. Okay, amazing.